Hello everyone, this is our next video of IPSec series. In the today's video, we are going to learn ESP and ESP modes. So let us start with the ESP. What is the ESP? So ESP stands for Encapsulating Security Payload. So this is the another protocol of IPSec security. So ESP is the second core IPSec security protocol. In the initial version of IPSec, ESP provided only encryption for packet payload data. Integrity protection was provided by AH protocol. So it means that in the previous version of ESP, we have only encryption, we don't have the authentication. And for the authentication, we have to use the AH and ESP combined together if needed. So in the second version of IPSec, ESP become more flexible. It can perform the authentication to provide integrity protection, although not for outermost of IP header. So in the second version of ESP can provide the encryption plus authentication, but still the outermost of the IP header packet will not encrypt it. So ESP provides authentication and encryption in the IPsec packets we just discussed, and ESP IP protocol number is a 50, and in case of AH, IP protocol number is a 51. So the difference between AH and ESP, major difference is in the AH we don't have an encryption. In the ESP we have an encryption plus authentication. That is the reason all organizations are using ESP, they are not using AH. So now let's discuss about the ESP modes. Just like AH, we have a tunnel and transport mode. Same with the ESP, we have also tunnel and transport modes. So what is the tunnel mode in ESP? ESP creates a new IP header for each packet. The new IP header lists the endpoint of the ESP tunnel, such as two IPsec gateways. So in the tunnel mode, we have a endpoints of the ESP tunnels like IPsec gateways as the source and destination of the packet. Because of this, tunnel mode can be used with all three VPN architecture model. So ESP tunnel modes is supported by all three VPN architect model, can encrypt and protect integrity of both the data and the original IP header. So it provides the integrity, means the authentication and encryption of original IP header of the packet. So if it's protected, then obviously it can prevent the unauthorized parties to encrypting the IP header, conceals the nature of communication such as actual source and destination of the packet. So it means that once data is encrypted, even the outer ring of the IP header is encrypted, so nobody can change or modify the data. So it enhances the security. So if authentication is being used for the integrity protection, each packet will have ESP authentication section after ESP trailer. So if you are using ESP authentication, then we have another header in the ESP packet we call as a ESP trailer. So we will see these all packets, we will learn these all packet in the upcoming video. So for now, the tunnel modes. What is the tunnel mode? So tunnel mode is having what actually tunnel mode is providing. So we can hear that. So ESP creates a new IP header for each packet. The new IP header lists endpoints of the ESP tunnel as source and destination, because tunnel mode can be used for all three architectures. So tunnel mode can be used for all three architecture. It provides the integrity, it provides the encryption, so no unauthorized parties can decrypt your data or modify the data. So if authentication is being used for integrity protection, each packet will have ESP authentication section. So if we are using authentication for integrity protection, so what is integrity? So integrity means that hashing. So in the previous video we discussed this hashing process in the detailed way. So where we have a keyed based X, we have a standard X. So in the key based hash, we have a data plus key, then we'll get the hash value. Then we'll compare both hash on the both side, we'll get the same hash or not. If we get the same hash, we confirm that this is authentication. So that process we call as the integrity checks. So we have the packets of the ESP tunnel mode packet. So what is the ESP tunnel mode packet? So this is the ESP header. New IP header is added. So let me change the color. So ESP header is added. New IP header is added, and this is the original IP header. And this is a transport and application protocol. Now ESP added ESP trailer, and we are using authentication in ESP. Then that trailer will also add after ESP trailer. So if we go down this packet, so we will see that original IP packet to ESP trailer, it is encrypted, and till ESP header let me till ESP header to till ESP trailer, it is being authenticated. So it is mentioned that. So we confirm that we have a integrity protection, so we have authentication protection. We have a encrypted packet plus authenticated packet. We call it authentication or integrity checks. So both is available in case of ESP tunnel mode. So now the another mode is a transport mode. So compare to the edge, similar to the edge. So in a transport mode, ESP uses the original IP header instead of creating new one. So in the transport mode, we are not this transport. In the transport mode, ESP will not create a new header. Instead of that, they will use the original IP header. So this is the difference. In ESP tunnel mode, they are having the new IP header field, which that ESP tunnel mode ESP will add, but ESP transport mode ESP uses the original IP header instead of creating a new one. So ESP can only encrypt and or protect the integrity packet, payload, and certain ESP component, but not IP header. So even it is visible that IP header will not encrypt. Other than that, it is authenticated, and second one is the till the transport that to ESP trailer is the encrypted, but IP header is not encrypted. So ESP transport mode generally only used in host to host architecture. Transport mode incompatible with the NAT. So the uses of this ESP transport mode is it's a suitable for host to host architecture, and transport mode is a incompatible with the NAT. So what is the NAT? We discuss in the PCNSS series. So you can refer those videos where I have covered the source NAT, destination, and we perform the protocol also. So in general, NAT stands for network address translation, where we are changing any private IP ranges to the public IP ranges, or we also can say that we are translating any IP address to any IP address. Considering that, we can translate to any private IP ranges to within a private IP ranges. It depends on the scenarios to scenario, but the point is, in the NAT process, we are translating any one IP address to the second IP address. It can be private, public, private, whatever it is. So this is the another packet I have taken for ESP tunnel mode. So this is the original packet. So in the original packet, we have that IP header, TCP header, and data. So what ESP tunnel mode add in this ESP tunnel mode? So till this pointer, that ESP will add their ESP header plus new IP header. This is new IP header is added, and this ESP header will be added. Further ESP will add ESP trailer and ESP authentication. It's optional field. If needed, we can, like ESP in the configuration, we can add it or not. It's optional field. So we can notice that new IP header field is still not encrypted nor authenticated. So this is the one example of the ESP tunnel mode. So I have a one more packet of the ESP tunnel mode. So this is the detailed view of the how that ESP packet will looks like. Let me do the some zoom so that more visibility can be happen. So we can see that this is the original IPv4 packet. In here, protocol is equal to TCP. Now protocol is equal to ESP. So this is the new IP type. So what ESP will do? This is the ESP. So ESP components. In the ESP components, we have a SPI similar to the H. We have that sequence number, and we have that IP header, and we have that TCP payload, means the actual data it is. Now let's go down more so that now we have the another fields. In case of ESP, it was not there. In case of H, we have a padding fields, pad length and the next IP. So this is added here. So next IP will be the IP header. So these are the some components which we, even in the next video I will explain that what is the SPI sequence number, IP header, and what is the TCP header plus payload. Will discuss the padding in the next video. So for this video we can see that in the this is the original IPv4 packet, and this is the modified by ESP tunnel mode. So in the ESP tunnel mode, the protocol field TCP will change to the this piece ESP, and this is the ESP components, SPI sequence number, IP header, and TCP payloads. So I have another examples for this is related to that transport mode. So similar to that, this is the original IP packet. So in the original IP packet, so as we just learned that they will not add any new IP header. So what they are adding? They are adding the ESP header in IP header only. So this ESP header is added and ESP trailer will add, and till that point ESP, let me change to the another color, TCP header to TCP ESP trailer, the packet is encrypted until the ESP header to ESP trailer authenticated. So this is the outer, like this is the discussion way of the ESP transport mode and general packet view, I would say. And now we have the detailed packet of the ESP transport mode. So in this mode, this is the original IP packet. So what fields will be changed? So protocol is equal to TCP. Now they will add the protocol is equal to ESP. Now this is the new IP type, and this will be the IP header which was earlier. And after we have a ESP, so we have that ESP components. It is similar to that tunnel modes. And now we have that next is equals to TCP. So we don't have a IP, so we are not adding any new IP in case of transport mode. In the H, even we are not adding new IP header in case of ESP also, ESP transport mode. So also we have that padding values, padding variable, padding length, and that TCP is equals to X next is equals to TCP. If I go back to just to show you that what was the on the tunnel mode, so if we can clearly say it is that next is equal to IP. So in this field the IP field will add, but in case of transport mode there will be the no IP field will be add. So this was the major difference. So I think we covered a lot for this video, that ESP. So in the today's video we have learned what is ESP, what are the ESP type modes, the tunnel mode and transport modes, what are the difference between the tunnel mode and transport modes. We have go through the packets of the tunnel and transport mode. So for this video I'm winding up with this. So I hope you enjoy this video a lot. If you enjoyed, please hit the like button. It may help us to create a new video. So for this type of video, please subscribe Firewall Experts to stay connected with us. Thanks for watching Firewall Experts.